All right, you're welcome again. We want to look at how to measure our landmark error. Uh, you see, last time we did we know that we did two digitization. If you remember very well, so we need to. The purpose of that is because we want to measure our landmark error. Because the process of extracting landmark coordinate will always be associated with some degree of measurement error. And this can result from the inconsistent tilting or pitching or rolling or even the of the specimen or non-congruity of landmarks, sometimes a difficulty in pinpointing the landmark locus. This could cause a lot of errors. You cannot avoid the error in landmark when you landmark manually, but you can minimize it. Okay, so we're going to be looking at how to compute the error using ANOVA concept and the landmark we have digitized. So let's see how we do this, and we continue from there sequentially. All right. So the first thing we'll be doing is that we're going to bring in our data. So don't forget we have already run the landmark. We have read in our data, and we have also computed the GPA, if you remember. And see, now we have, but you can remove the third and fourth lines, the plot all specimen and the plot of GPA. You can remove that one, but you can leave the two there. That LM and GPA you can leave that because we need it for further analysis to compute because that always remains because you have to run each time you that is if you have closed your session, you have to run again. So if you have not closed it, you can leave it there while you continue with other computation because it still be running. All right, so let's kickstart let's begin. What we can do. So we want to see last time this is the first one we did last time. If you remember, we did we have what do you call it? I want to bring in the second one now, the second TPS file. Okay, so the first one we had this second one now. So let us bring it in here and combine them together so that you can perform the analysis. All right, so I'm pasting that one here now. So I will open the each of them so that I can combine them together so that I can perform the analysis now. So let's open this and see what is inside. All right, you can see what is inside the two of them. So I'm going to copy one and add to the other so that you can have the two in one so that you can use it to run our experiment. All right. So you can see that two of them, they are not differ too much. Okay. All right. So it's not far too, you can see that not differ too much. When you look at it now, you can see I'm trying to see each of them now. So we bring it together. We are going to save down as another file name. Let's just call it a let's call it 3. Call it always 3 now. So still at TPS, make sure that you select the first option there, so that you will not save as TST. All right. So we have changed the file name here now, so make it a TPS3 now, or all races 3, so that we can run the analysis now. So let's see what is inside the limb now. So let's see the difference. What's the landmark? So we have now we have 22 landmarks, dimensional, and 120 observations now. So not like before that we have 32. Now we have 220 observations. So that is very good. So we can now proceed and run our analysis. All right. You have to always check this once in a while, so that you can know what you are working on. Yes, you'll be working on something different. All right, so let's go and run our analysis now while we close this. You can see that, you can even see that they don't differ that much when you look at it now, but they are not exactly the same. Both the first and second, they are not the same exactly, but they don't differ too much. All right, so let's close. We're going to run our code on that. So let's go ahead and do that quickly. So this is the one we did before, that I converted last time, that we need the race and sex group. So this demographic information is very important. We need to keep it, so you can discard the rest. So why we keep it? So I've done that. I've recorded. So this is it here. You can open it now. So this is, I've separated that races, and the sex. I've separated it in the different file, so that I can bring it in. That's because we need the group. Okay, this particular group, we need it. So that's why I save it as your CSV file. So you can do the same, and so that you can keep your own. You can do for another like that. So let's bring it in now and see what is connected with our data, our code. So let's call it measurement error now. So let's call it races, and let's read it in as CSV file. And now we so let's run and see what is and it's run. So we can also see what is inside the file also by let's use a head, so that you can see just lines from the what is inside. So you can see now we have ID, races, and sex. That's what we have. We want to show everything, just to show few of them. So this is just 6 lines. All right. So that is what we have there. We want to now make a variable from the race and the sex now, right? So let's create a variable of sex and the two of them. So let's run that and see also. So we have run that. That is on. So let's go further. We have made variable from that. So we have the groups ready now. So let us try to see how we can combine them together. Let's create a model by creating a a framework and combine those two together, the GPA, the sex, and the race. Let's combine together now, so you can have one file. You can call the file at any time we need it, so we'll not be having to do them one by one. So let's call the GPA. Don't forget, GPA has so many things inside. It has a structural size, okay? It has a coordinate file side. It has iteration. It has many other things inside. Don't forget that. So we want to bring them together now, and save it as one file called DTF, okay, as a architecture variable for it. So let's do that quickly. So let's run the file again. All right, so now let's call it let's not create error now. Error. Let's call it error. Okay. So we are going to call our GDF now. So call GDF. We need coordinates. So we are not this one is coordinate, not size. Don't forget, when you are doing this, you have to bring in the coordinates, not the size. You need the shapes. The coordinate is the shape, not the size. If we go in Morpho for example, it gives you the result for both size and the shape. But we don't need the size. We need it for the shape. So we are looking at the shape now, not size. So we are going to bring in the coordinates only. So let's select the coordinates and down for our analysis. Right. We have the race and the sex together, and we bring our data in. Our data is GDF. Don't forget that. All right. So let's run and see. You can perform ANOVA on our variable A, but I think no. We don't need to perform ANOVA on it. You can even just summarize it. That is enough. Okay, just summarize the ERR variable. Just see summarize. So let's run it. You see the result output. All right, you can see the result here. So this is our digitization error result now. Okay, for 2 repeats. You can have 3 repeats in your own analysis. You can have 3 repeats. So, all right. Like I said, you need 3 repeats for your own. So, to make it a standard research analysis. So you can see that our mean square error is what is important here now. You can see the two are significant for both race and sex, but we need our mean square error for residuals. Okay, so for the residual we have a mean square error. So the mean square error now is very important. So this 0.0003 one something. So you have to use that. That's what you use in your analysis. As your measurement error. Okay, mean square error, and you can even convert to percentage. All right, convert to percentage. Maybe if you convert to percentage now, if you multiply this to times 100, to give you a 0.0371. I think. So that is how to compute that analysis. So this is what we do. So you can bring out this particular table now and bring it and copy it and your research analysis for landmark measurement error, then you can explain briefly on it, and so most importantly, you let them know the mean square error, and just identify it, your result, your discussion, so that you can show that this is what we got, and probably compare with other analysis which have a higher result, and you can also maybe yours is lower. So see again in the next section when we look at another subject, another topic in this particular course. So thank you so much for joining us today. Thank you so much. See you in the next class. All right.